Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Engineering. Today, in my session, we are going to see about the introduction to magnetic materials. So, here we are going to discuss about the introduction that contains magnetic materials and then magnetic moment, and then we are going to see about their classification, that is classification of magnetic materials, that is diamagnetic material, paramagnetic material and ferromagnetic material, antiferromagnetic materials and ferrimagnetic materials. So these are their classifications. So introduction. So first we should know about what is called magnetic materials. So the materials which are attracted by a magnet or magnetic materials, and we know the very well example of iron, nickel and cobalt. So that are the magnetic substances made up of these materials, so attracted by a magnet. So magnetic materials can be magnetized, or we can say that magnetic materials can be converted into magnets. Next one is the magnetic moment. So magnetic moment is known as magnetic dipole moment. It is the measure of object's tendency to align with the magnetic field. So magnetic moment is defined as magnetic strength and orientation of magnet or other object that produces a magnetic field. So the magnetic moment is a vector quantity. So that will possess so both magnitude and direction. So next we'll see about the classification. So already we discussed the magnetic material can be classified into different categories, so based on the magnetic parameters. So the base that is classified into three, that is dia, para, ferro, and then ferro has a deformations, that is antiferromagnetic materials and ferrimagnetic materials. So let's see first about the diamagnetic materials. So diamagnetic materials are substances that are usually repelled by a magnetic field, and the electrons in an atom revolve around the nucleus and that will possess orbital angular moment. So the resultant magnetic momentum in an atom of diamagnetic material is zero. So common example for this diamagnetic materials are, we know that is a plastic bodies, petroleum substances and then copper. And we know that so due to the properties of every material only we'll have a different applications. So let's see the properties. So diamagnetic materials are repelled by a magnet. Magnetic susceptibility is a small and negative here. The relative permeability is slightly less than unity, and diamagnetic materials are independent of temperature. These materials do not obey Curie's law. So the magnetic dipole moment is small and opposite to the magnetic field H. So these are the properties of diamagnetic material. So next we'll see about the paramagnetic materials. So it is we can say it is a weakly magnetized material, and it is in the direction of magnetic field when placed in the magnetic field. And paramagnetic materials have permanent dipole moment or permanent magnetic moment. So if we remove the applied field, the materials tends to lose their magnetism. This is because thermal motion randomizes the spin orientation of the electrons. So it is a weakly magnetized material. So properties: when the net atomic dipole moments of an atom is not zero, the atoms of paramagnetic substances have permanent dipole moment due to unpaired spin. The substances are weakly attracted by the magnetic field. In the uniform external magnetic field, paramagnetic substances move from a weak field region to the strong field region. And a paramagnetic rod sets itself parallel to the field because the field is strongest near the poles. The paramagnetic liquid in a U-tube ascends in the limb, which is between the poles of magnet. The intensity of magnetization is very small, positive, and directly proportional to the magnetizing field. So magnetic susceptibility is small, like diamagnetic material, and there it is a negative and it is a positive here. The relative permeability is slightly greater than 1. The field inside the material is greater than the magnetizing field. The magnetic field lines become denser inside paramagnetic substances. Magnetization of paramagnetic substances is inversely proportional to absolute temperature. So this is about the properties of paramagnetic material, and now we'll see about the ferromagnetic. So these are various kind of magnetism, so out of which it is the strongest type. So ferromagnetic materials are the strongest material, those material which exhibit a spontaneous net magnetization at the atomic level even in the absence of external electric field. When placed in an external magnetic field, ferromagnetic materials are strongly magnetized in the direction of field and it is strongly attracted by the magnet. These materials will retain their magnetization for some time. Even after the external magnetizing field is removed, this property is called hysteresis. It is called a hysteresis. So let's see the properties. The atoms of ferromagnetic substances have permanent dipole moments present in domains. Atomic dipoles in ferromagnetic substances are oriented in the same direction as the external magnetic field. And here the magnetic dipole moment is large and it is in the direction of magnetizing field. The intensity of magnetization is very large and positive and varies linearly with magnetizing field H. Hence, saturation depends on the nature of the material. So, here the susceptibility is very large and positive, and H is the strength of the applied magnetic field. So, these are the basic three magnetic materials, and we'll if we go and see with anti-ferromagnetic material that comes from the ferromagnetic material. So it commonly occurs among the transition metal compounds, especially oxides. So examples may be hematite metals such as chromium, alloys such as iron, manganese, and oxides such as nickel oxide. So these are the examples of our antiferromagnetic material. And what would be the difference? So difference between the ferromagnetic and antiferromagnetic material is nothing but the magnetic moments that align parallel to the applied magnetic field in ferromagnetic material, whereas in antiferromagnetic materials that will have an anti-parallel magnetic moment. So this is the difference. So this result in a positive magnetism for ferromagnetic and zero total magnetism for